senior JavaScript engineer at 4 Kitchens. And I'm here to talk to you about some work that was inspired by some things we built for MVC, and that's components as data. It's a cross-platform GraphQL-powered component API. Now, maybe that sounds like a lot of buzzwords, and you wouldn't be wrong, but it is actually what we built, and I think it could be useful for some of you. So we're going to talk about different approaches to API design, and we're going to talk about this concept called the Decouple Line and use that as our guide. So components are pretty much everywhere. Like, they are the building blocks of UI at this point. Anyone and everyone in front-end development are talking about components, and they're using component-driven design. They're using frameworks that are helping them build components. This word is plastered everywhere. You can't get away from it if you're even tangentially related to the front-end world these days. But what is a component really? We know that they're everywhere. They're on all of our devices. They are prolific at this point, but they're kind of abstract. So I like to define a component like this. A component, at least in the sense of the term UI component, is a function of rendering properties and state. So we'll define those terms. So I think we could define these pretty simply, and I'm borrowing this term props from React, but you could think of that as parameters or properties. Props are read-only external data that gets passed to the component as a dependency to it. It's kind of external, it's given to it. You can think kind of like an HTML attribute, right? State is local data that changes over time. So anything that you have heard of that is stateful has this kind of idea that it is going to change over time. So props and state are used in this way to kind of, in the rendering of a component, to declare a representation of the UI. So that's what I mean when I say that rendering is a function of props and state. So what's an example? Here's a real basic example of a component. So we have our little switch component here. And it's small. It does one thing. But if we could describe this in terms of those definitions we made of props, state, and render, then this switch basically could have a label. This one is labeled as switch. And its state would be whether or not the switch is on or off, right? And then naturally, this switch could look like anything. So your render function is ultimately going to use the props, the label that you have inside of props, the state, whether it's on or off, to make style choices, to make markup choices. And so there's your example. But there's another property of components that are, I think, why they're so successful, and that is that components are composable. So we could take that switch component and we could add it into a row component, right? And if we take the row with the switch inside of it and we add a couple rows, then suddenly you have a settings screen, right? So components compose, they're renderable things that have state and properties. So, regardless of the framework, components are here to stay. We're going to be talking about components when we're building UIs in 10, 15 years, I would say. If we're still building UIs and the machines haven't taken over. Sorry about that. I let that one slip. So, whether it's Swift UI, views, Flutter widgets, React components, front-end engineers like genuinely enjoy working with these paradigms. It's fun. It's like the Lego generation's dream that we get to actually build things like this and compose them like this. But we're not really here to talk just about UI. This is components as data and an API talk. So I'm going to stop gushing about components. I think we all know that it's a pretty good abstraction for building UI. And I want to move on to talking about APIs. And we'll get back to how this ties into APIs later. So there's some key pieces to any application. Components are one of those. You'll see that over on your right. But there's all these other decisions that have to be made. So you have your database, you have your business logic, you have data fetching of all sorts of different APIs, maybe also from your database. You have feature flagging, A/B testing. You also have your component library. And then finally, you render it somewhere, whether it's on an iPhone or a desktop, doesn't matter. But these are some of the key components of any application. So there's countless ways that you could combine all these things, and we've talked about a lot of them at this conference. We're here and we talk about decoupling our architectures. And so we often talk about, who should decouple? What kind of organizations should decouple? We talk about what kind of projects should decouple? When is a good time to decouple? Why and how to decouple at this conference. But one thing that we don't ever talk about, at least I don't hear much about it, is where do we decouple? That's a decision that has to be made as well. And I think that it's often assumed that we're going to decouple in a pretty typical fashion. So I wanted to talk about the idea of where you might decouple. I'm going to use this concept called the Decouple Line. All right, so here's our Decouple Line. It moves around your architecture and it slices it in half with this magical sword of HTTP, and it will draw a line in the sand and say, here you decide the interface for your API. Let's start with the typical API architecture. A typical API architecture is going to decouple pretty close to the database, and the assumption is often that you're going to essentially be exposing your raw data model. Like almost literally, tables in your database are exposed over HTTP. And there's these kind of APIs are going to provide listing functionality, complex filtering, sorting, selecting of fields, right? And a bunch of other things like create, read, update. They're loosely mapped to these HTTP verbs that we have at our disposal of post, update, post, get, post, patch, and delete. The JSON API spec is a great example of how to build this kind of API, in my opinion. It provides a very resource-based opinion on how to format one of these APIs. The queries that you make with this kind of API are very low level. Get me all of the blog posts from authors with name Fred and also whose age is less than 7, right? So you can almost make these, this is a pretty good query. You can make these almost SQL-like queries in an API like this. They're low level, extremely flexible, extremely powerful for an application that needs access to raw data. We used this at NBC for a long time, and we still do today. But if you look at this line, so if this green line is kind of dividing the back end and the front end, this leaves a lot for the front ends to do. This leaves business logic for them to implement. This leaves all of the API, all of the fetching of other APIs. Maybe that happens in a proxy, maybe not, but either way, you still need to implement A/B testing and feature flagging as well, somewhere down the line. So this leaves a lot to be taken care of for API consumers, because you've basically just kind of opened up an interface to your database. So this is often the assumed architecture, I would argue. But maybe, yeah, so this one I think I would attribute to kind of like typical REST, where it's very resource-based and you're concerned with creating, reading, and updating things. But let's move the decouple line over a bit to include business logic. So what kind of API do we get when we include business logic in the API? Well, it's not really only concerned with resources at this point. It's not really only concerned with filtering and creating and reading and updating, deleting all these operations. It also can include all sorts of other things now. And this almost gets into like an RPC kind of territory where you're executing procedures via an API. A great example of this would be Stripe's API. Stripe is a payment as a service product. So Stripe obviously is going to allow you to list out different charges. They're going to allow you to get a single charge, very like atomic and RESTful in that sense. But they're also going to allow you to do something called capturing a charge or disputing a charge, right? What is that? That's business logic. And in the behind the scenes, literally what you're paying Stripe for is to implement that business logic for you. Because otherwise you would have to go and know the exact fields across their entire data model to patch. Or maybe if you dispute a charge, it deletes another type of entity. They're taking care of all that for you. And this is what I mean when you're including business logic in your API. This is extremely powerful for product companies. And I think if it was paired with, so this is just more than just entities. But if you pair this or even the prior architecture with Helios, which stands for Hypermedia as an Engine of Application State, it's very wordy, it barely fits on the slide. Thanks, Roy. But I think you can get an extremely powerful API out of something like this. Like imagine Stripe, if they built a little bit more RESTful API with Helios, they could provide these links to you. So let me give you an example, because Helios can be kind of hard to explain. So I'm going to use maybe a little bit of an interesting example. I don't know if it counts as Helios. We'll see. So I'm going to use pagination as an example. It's kind of like Helios. So in the example that we've all had, right, where we have a listing page, say it starts out that we have 100 things in this list, right? But requirements change, we ingest some more data, content entry happens, and now we have 5,000 things. And if we try to fetch that, then not only is the API going to struggle, it might not even allow you to do that. And also, no one wants to look at 5,000 things in a UI. That's a horrible user experience. So naturally, you introduce pagination. And so I think a good API will provide this for you so that you do not have to implement this from the back end, from the front end. So that the state lives in the server, ultimately, and is described in your links. So JSON API has this idea of links. So we could provide a next and a previous link in our listing response from the server. And if you can read that, it's basically giving you a page number for the next link in your pager, and it's giving you the size of the page. And the idea is that the UI should wire this request up to a GET request and use it to fulfill the next page, right? So last also could be calculated based upon the total number, the total count of the list. If some of the links don't exist, then you don't create the UI. Like if there's no next button, if there's no next link, don't create a next button, right? So at this point, the server is driving the state of the application. It's not like there's a hard-coded next button in your listing component. It's driven by the data. And the cool thing about this and about Helios in general is that it's just, the UI is completely ignorant to it. They're agnostic to it. So we could change our paging approach to an offset-based paging approach, and front ends they don't know any difference. They just know that when I go and get the previous link, then I get what I need. So this is a super powerful approach, and I think could be a lot of product companies. I think the value they actually provide in their APIs is implementing the business logic, the hard parts, so that the front ends don't have to do that. So let's move it. Let's move the decouple line again. So we're going to move it all the way over. That's an interesting one. It's not really an API anymore. I would call this is just the monolithic approach, right? If your dividing line if this green line is HTTP, then what we have here is we're serving HTML, CSS, and JavaScript over the wire, and we're not really talking about APIs here. I guess technically, if we want, for the purpose of the talk, we could call this an API. So I want to discuss the elephant in the room, and that is that I think the word monolith has become this low-grade insult in the web development community. And it's kind of silly, in my opinion. I think it's a case of guilt by association. I think folks have worked with very large systems that are old and have had to change over time, and they are mad because it's all in one code base, and maybe git pull takes a long time, and they're just really frustrated. And frankly, I think that people that have worked on these big monoliths blame the fact that its constituent pieces don't communicate over HTTP on the fact that it doesn't work well. And that's just silly, right? Like if you take a poorly written application and you take the lines of the interfaces of your programming interfaces and you separate it over HTTP, now you have two problems, right? This is not this is not a some kind of silver bullet. And I think a lot of the hatred pointed towards monoliths is actually just hatred towards old code bases, which, newsflash, your microservices are going to be super old pretty soon, and you're going to have a very difficult time maintaining them. So I think that's guilt by association, and I think monoliths are a perfectly fine approach. It's not some kind of automatic spaghetti code situation. Okay, so that's a decision that's to be made. Let's do another one. So this one we're going to move all the way over here. This one's weird. I don't know, maybe this is a little bit of a stretch, but I wanted to use it for demonstration purposes. I would call this, what is an application where the database lives in the client? It's an offline application. It's an application that doesn't require the network to work. And this is a real decision that actually needs to be made by some of us in the room. If your client says, hey, we have people that go out into the field and there's very poor network connections, we need their application to be snappy, we need it to work. What do you think all these iOS developers are doing? They're putting SQLite in their iOS app, and then they're syncing the data behind the scenes to a server, right? So that's an important decision to be made, and frankly, how that syncing works out is a whole nother talk that I'm not going to give. But I think it could work out in a way that encourages decentralization, which frankly is something we need these days. If an application doesn't require some big co TM server to run, people actually can do what they want to do regardless of big companies how well they're doing, or if their servers are up or not, or if they're selling their private data. It really should belong to them. Okay, I'm going to step off my soapbox now. But this is hard. This is really hard to do. Imagine an application that's been offline for 3 weeks, and a different node that represents the same user that needs to sync has also been offline for 3 weeks. Like, now you have CAP theorem to deal with. Like, how do you keep consistency over a partition like that? Very difficult to deal with. I think one area to look into if you ever do run into needing an offline app would be to look into CRDT. CRDT stands for Commutative Replicated Data Types. And it's a way to kind of try to solve the distributed data problem of how do I synchronize nodes in a system separated by a partition. CRDT is hard because how do you define operations that are commutative? You're dealing with like math here, right? So addition and subtraction are commutative. No matter what order you add something up in, it's always going to end up the same. Getting that to work with your system is very difficult. But it's something to consider. There's a lot of research happening in distributed computing these days. Okay. Yeah, I know. That was a weird one. So finally, let's get to what we're here to talk about. This is components as data. Yeah. So components as data absorbs a lot of work from the front end. It absorbs business logic. It absorbs data fetching from disparate APIs and services. It absorbs A/B testing, feature flagging, and even your component library. And that's where it gets interesting. And that's why I like to call it components as data, even though I just literally made that up. So components as data means the API serves a tree of their UI in terms of JSON. So what does that actually look like? So basically your components are mapping to JSON. That's components as data. So let's give a quick, simple example just so that we can get rolling here. Here's a very basic components as data example. We have here one component, right? So we have our hero. This is an important field called component. And then we have data. Data contains all of the props, right? So we defined what a component is earlier in the talk. Data is going to contain all the props needed for rendering your hero. And maybe there's state, but the server isn't concerned with state. The UI state should be handled on the front end. So it reminds me of something, and it's like the first lesson I learned when I started my Drupal 6 site back in 2009, and it was that, hey, you're putting way too much logic in the templates. You're putting way too many logic, like just because you have PHP doesn't mean you should put all the logic in the template, in your TPL files, TPL, whatever you want to call them. Right, this is like Drupal 101 best practices. And yet, when we decouple at the line of the data model, we leave all of this work for front ends to do, and it all ends up in our template layer again. So we have these super complex React apps that, yes, like there's a lot of trade-offs there that are worth it, but also imagine if you have multiple teams. So you have the web team that implemented all this business logic, but then you also have the iOS team, and you also have the Android team. And the reality is that across platforms, what your product does for a user is fairly similar. And that business logic should probably be centralized somewhere. So I think that this is, it harkens back to a lesson that we all know already. and yet I think history kind of has repeated itself. So UI is a vehicle for business logic. I don't think it needs to be tangled up with your business logic. You can see React trying to deal with this with the hooks stuff. So enough theory. What does this actually look like? So here's NBC.com. This is the application that I at least first used this approach on. I'm sure many others have done similar things to this. NBC's whole business model is giving people things to watch. So you'll notice like this slideshow up at the top with different slides, right? And here we have shelves full of series tiles and video tiles, right? So you can start to imagine what the component library for this front end looks like. There's a slideshow, there's a slide, there's series tile, there's video tiles, right? And these are basically listed out here and can be, the business logic around some of these things are going to be like trending now, which is based upon popularity and watching trends that our data science team calculates. If I were logged in, you would see a top picks for you shelf. The business logic for that is complex, and our data science team calculates for each user a personalized set of recommendations of series. Continue watching. Pick up where you left off, right? Favorite shelf. Here's the business logic of NBC, and it's actually a fairly simple UI. One thing I want to mention about this components as data business is that if you have a really complex transactional tool that you're building, this might not be a good approach because this gives a lot of work for the server to do. So we started out here at NBC, and the queries that we were getting from consumers were very complex. We were having to field questions very often about how to query the API. And there's a lot of reasons why those kinds of things can happen, but I think what we were coming up against was very large, very complex computationally and complicated queries that these front ends were trying to write in order to fulfill the business logic. They were all writing generally the same queries. Maybe one or two little parameters about what platform they were on would be different. Okay? So this is where we started. So we kind of discussed the data model. So let's kind of try to apply this components as data approach to NBC and kind of see how we built the page I showed you. So we have our slideshow, which contains a slide. We have a shelf that could contain like a series tile, a video tile. I've trivialized this for the sake of the talk. So there's another thing that I need to address in this talk. I used the word GraphQL in this talk, and this is not a GraphQL talk. I will just be upfront about that. There's a few reasons we use GraphQL to implement this, but I wanted to be clear that there's no reason why this couldn't be implemented in any kind of API format, right? This is not a requirement at all. I find it to be nice, though. There's something subjective about it. Objectively, GraphQL, the way that its type system integrates with its query logic it's just hard to beat. So I think that because we were dealing with some pretty complex queries that did come into play. But that's kind of all I'm going to talk about as far as GraphQL goes. I am going to show you some examples. And we're going to do it in GraphQL for the sake of the talk. So here we have our schema definitions. So we have our interface that is a component, and it contains a field. You saw this on the hero definition that I showed you earlier. There's a component field that is a string, and it's going to pretty much, we usually have a directive that just automatically resolves it to its parent type, because you'll notice that that in the video tile, the type actually maps to the component in the front end. So as they're querying, you'll see that what they're actually querying for are the components that they know how to render. And the rest of the business logic and data fetching happens in the server side. So this video tile implements a component, and it might contain a treatment field, which are kind of like our version of CSS classes across platform, where we can tag a component as a certain variant. And then you'll see that the data field is a different type. And that was a very interesting decision that took a lot of thinking. Decoupling the component from its data actually is really what we were looking for here. Because the reality is that this video data type could be used on another UI component that necessitates video data. So the video tile basically composes with the video data via the data field. And you'll notice that these fields look pretty familiar. It's like an image, a title, percent viewed, right? So for that little bar to see how much you've watched, and then some secondary titles. Same goes for the series tile, and then you'll see we have a union of the video tile and the series tile, making a tile. And that's important because what is a shelf but a wrapper around tiles? So shelf data, you can see, it basically has a title, like so top picks for you, right? Or continue watching, or favorites. And then it's going to have items, which are described as an array of tiles. Here's another piece of the puzzle. It's not, there's another layer of kind of like interface layer that you need if you're going to start doing more than just like a small little UI component, and that is different sections of the site. And we thought a lot about layout and how to do things, and basically what we landed on was just creating some different interfaces that people could pluck fields out of from the page response and place in different places. So that'll make sense later. Here's a shelf. It implements a section, which has a typo in it. A section has no component field, but it can have a treatment field. And it also implements component. And it has shelf data like we described above. But then there's also featured interface, right? And so the slideshow, it's kind of up at the top, right? So it's kind of featured. We're going to create this field that is featured. So the slideshow implements featured, and its slideshow data has a bunch of slides, right? So you get the picture here. So the query, the page is going to look like this. So the page is also a component. It has a featured field, which is going to contain anything that implements that featured interface. And then the sections array, that's going to be any section. So right now we just have a shelf as a section, but the reality is that we have lots of different components that implement that interface that could show up in the sections array for any reason. It could be an A/B test, it could be personalization, all those reasons I talked about earlier. Okay, so let's look at a quick example of what it's like, and I fear the worst about this. Is that working?
Yeah.
Okay. It's totally not viewable by me, so I'm going to have to crane my neck here. Okay, so here's what a query looks like. And I also want to stress that there's absolutely no reason why you have to create an entry point called page, right? That's one decision we made, that we were going to want to make these queries by pages. But we also have lazy loading that occurs where you can fetch an individual shelf, right? So you could have a shelf field, you could have a page field, really anything. So this is basically your entry point to the query. So here we're going to fetch the home page, right, for this user on the web platform. So you can kind of see what these queries start to look like from the consumer side. You're basically passing the context needed to fulfill the business logic that only the UI really can know. So they're authenticating on the UI side. getting a user ID. They definitely know what platform they are, and based on routing, they know what page they're on. So here we have a couple fragments. We're fetching the featured section, we're fetching the sections array, and we're getting our shelves. And so you can see here that it's just going to basically match up with our types, right? So you can kind of see, if we go to this kind of documentation, essentially becomes a design schema. Anything that's described by the schema, the UI needs to be able to render. So let's look at sections. Here, the iOS team could say, okay, well, I'm building out my sections renderer. So the different implementations of sections are shelves. So okay, so I need to be able to, inside of a section, render a shelf. As far as the layout of a shelf is concerned, they need to be able to handle that. So if we put something wild in here, like here inside of the section, you need to put a slideshow, like there could be 5 slideshows interspersed in the page, they would need to be able to handle that. It truly is a design schema at that point. Okay, so that's what it looks like kind of to implement the API side. And, you know, obviously your mileage is going to vary on what the business logic and the A/B tests are, right? This is really just a format. What does it look like to render a components as data API? It's pretty generic, and that's the point. So let's start off with something simple. Here we have a slideshow. The slideshow has state. That's what you see here being used on use timer counter. Oh, are we still looking? Did I get out of sync here? Oh no, it's happening. Okay. Think twice about using web technologies for your presentation. No, I'm kidding. It's great. So, slideshow has state, a timer counter, right? Every 5 seconds it's going to increment a slide number, right? So there's your state. But then also it receives props. This is, sorry, I should have mentioned this is React. This is a React component. I'll be using React for the sake of the talk because I think it's fairly familiar. So we have our slideshow component that takes props. It has the timer state that's going to change over time. And then we start to actually render the slideshows, the slides. So we use this generic render component. Okay, and it contains a dictionary of components, and it's going to pass the slide data from the items that we had. So if you remember, the response format has these items with different components inside of it. So those are slides. It's going to pass the slide data, and it's going to pass the state along to that component, right? Here's a boring slide. So let's skip down to these dictionaries because that's where it's actually interesting. So what you've done is we've basically defined these components in our component library: slideshow, slide, series tile, shelf, right? And we've partitioned them out based upon the interface of our GraphQL API. So when you're rendering a component that you know is a section, you know that, okay, I'm going to use the sections dictionary to render the component that I receive. And so in that way, you're basically dynamically rendering the application. So here's what render component looks like. It receives a dictionary, and it also receives the component field and the data field from your API. That component field, remember how I said it's special, it's going to be used to look up the component in the dictionary. So there you have the component, and you know, if you receive a component that you don't have implemented, you should probably actually throw there because that's a pretty bad. I just return null for some reason. And then you're going to just kind of like generically render that whatever component you just got with whatever data you just got, right? So So here's what like the app could look like for that really basic example I gave. So you're going to go fetch from your component API, and it's loading, and that's great. But then you have your different sections that we talked about, right? The featured section and the sections field. Those implement those different interfaces, so we pass in the respective dictionaries and generically render the UI. Make sense? That's really big. There's some advantages to this, and ultimately, when we built this out for NBC, this is what we were going for. These were the things that we were trying to go for with this kind of iteration of the approach. Simpler UIs. The simpler the UI, the less issues, like platform-specific issues there's going to be. The next one is centralized business logic, and it kind of goes hand in hand with the simpler front ends. With all of these platforms implementing the same business logic over and over again, we were getting these really specific, platform-specific bugs. Centralizing the business logic was a huge boon to not only performance, but also the simplicity of our front-end applications. That business logic can include all sorts of things now. Like, imagine all the possibilities, especially for these, like a simple thing like these shelves, like the kinds of decisions that could be made for how you order those shelves, right? So it could be personalized, it could be machine learning driven, it could be an A/B test. So we also centralized A/B testing and feature flagging. So no longer do clients have their own implementations of A/B testing going on, but we, because we own the component library, we're the ones that implement the A/B tests. And guess what? Every platform gets them for free now. So if you want to A/B test a different kind of slide, as soon as all the front ends have implemented that new type of slide, they are ready for that A/B test, and we can opt them in through something like API like Launch Directly. Also feature flagging. So imagine the Super Bowl. There's a This Is Us commercial, season premiere. Things get crazy that day. They get pretty wild. So what if we're experiencing some kind of latency? So let's disable personalization and let's just show editorial shelves during the Super Bowl. These are things that are possible from the server side, and they will roll out across platforms. And then also there's a lot of query optimization that we could do. So we can now do application caching that is shared across platform for anything that's not personalized. So an editorial shelf that's fetched for one person is now shared by everyone. That helped in getting around some of the caching issues that we incur from using GraphQL. So I guess what I want to leave you with here is when you're thinking about decoupling, when you're thinking about the architecture of your application, it's important to think about the problem you're solving rather than the solution first. And that's a very hard thing to do as an engineer. Like, it's very hard to do. We have these solutions that we have in mind that we want to go, and it's our big hammer, that we want to go hammer things with it. But I think you can start to some interesting approaches start to happen when you think outside the box. So that's my talk, and I'm happy to take any questions. Thanks. Anyone have any questions? Sure, let's get the mic.
So if you centralize something like personalization across all the various NC products that we have, does that mean that they all get, that they have to share the same personalization logic, or do you guys do something where, you may alter it based on the form factor? And if so, then are you not back at the same problem?
Yeah.
I'll take it.
I think are you basically asking what form personalization actually takes, kind of, and how it works?
Yeah. Well, like for example, like if I'm on a mobile phone, right, and I look at the feature content, maybe because I'm on my phone, and I'm gonna select towards shorter form content, as opposed to like, if you're on your Apple TV, which you would get normally, so that kind of thing.
Yeah, so that's a really great question, and I think a good way to describe this is that basically we provide the fields that are needed for both. So say there's long form and short form. We're going to provide a short description and a long description in the video tile, for example, right? And it actually could be that web does need short description, and right. And so in that case, the iOS team might use that field, right? And if there really is going to be, if there needs to be a personalization, like based upon a user or a segment, then that would actually happen in the server. So we would have one field that resolves differently depending on the person. Yeah, and that's the job of the backend at that time. Yeah.
Got it. So from what you're saying, prior that kind of logic was on the client and affected performance, and now it's on the server, and I guess through better caching, it increased or decreased performance, increased performance, and just makes more a better experience because you offloaded client-side processing on the servers. That's what you're saying.
In the specific example you gave, I don't think that would really affect performance, but when it came to the vast amount of queries that are needed in order to fulfill the business logic of something like a recommended shelf for a given user, there was some performance gains that were to be had there because we're on a server and we can do all sorts of connection pooling and application caching and things like that. Yeah.
Cool, thanks.
So it looked like you were just passing a component name and some data to each component in order for it to render. I'm curious about your schema in GraphQL. Are you typing each variant of data properties that can be passed to each different type of component, or is it just a generic data field?
Yeah, we are. We're that was what I mentioned about decoupling the type for the component from the type of the data. So the GraphQL types for the component are actually very simple. They're essentially a field called component that kind of self-resolves to the type, the GraphQL type. And then that treatment field, there's like some analytics fields and metadata fields that we also pass along. But then the data field inside of the component is a separate type. And so you saw I had video type, right? So video type could be shared from a video with a video tile, or on the video page, there could be some component on the video page that might need that data type. Yeah.
Thanks.
It's along the back.
I'm curious if this is a cleaned up version of the idea of render arrays.
I'm going to stop recording. I'm just kidding. It actually reminds me a little bit more of the AHA framework.
Yeah.
Right? And so I think there's conversations to be had, like actual serious conversations about how this could be helpful for people. But you're not wrong. It's the render array is the interface between the theming layer and the module layer, right? I'm trying to remember my Drupal. And so if that's the case, then that's exactly what this is, because the decouple line lies between the module layer and the theming layer, essentially.
Yeah, the part that got me thinking this was the slide that showed a JSON object where there was components and then the name of the component and
Yeah.
the data and the data. And I thought, I've seen that before.
Yeah.
I've seen a data structure that has the name of a theme hook and the data that is meant to be rendered by that theme hook,
Uh-huh.
and a later system that combines the two. And I don't think that's necessarily a bad thing. I think
No.
the Drupal theming system has so much stuff put on it that there's too much complexity for one person to keep track of, but this looks like a simpler version of the same idea.
Yeah, and I think one advantage that in this application that we have is the type system. Those fields, right, are all validated, and so yes, we have GraphQL types to ensure that this person this component that needs that field is actually asking for it correctly. There's this validation that occurs. Whereas if I remember correctly, you can kind of just put whatever you want in the render arrays and kind of pass it along.
Yes.
Okay. Yes. Yeah. Any other questions? We'll take it.
Thank you. This talk was amazing. Thank you a lot. I have one question though, about A/B testing. You put the line like the A/B testing happens on the server, but there must be a piece that tracks success of the user, right, on the front end?
Yes, there is.
Okay.
We pass that along. Yeah, there's metadata that we pass along in an analytics object. So in the reality, the component for video tile also has an analytics object, and it's going to contain a few fields that are needed solely for the purpose of reporting analytics. And those are not presentational; those don't go in the data field. They're only for analytics, and so they do have to implement basically a success call. They make an API call to a service that says they did the thing. Yeah. And the way that we do that is we pass along with the response a experience field. And what that does is it tells the consumer of the API, I'm a part of these A/B tests. And so based upon that information, I know I can report on that test, basically. So there is a little bit to do there on the implementation, on the consumer side. Yeah. Anyone else? Thank you, everyone, for your time.